Hello again. Now that you've gotten your start on Python Absolute Beginner up through task 5, we're going to continue. And at this point, you have learned how to create a variable, assign a value to it, such as a string or an integer value, and then use it in a function like print. Print is a function. And functions have these rounded parentheses, and you feed the function something to use. So we give it a variable, or we give it a string, or we give it an integer, or even a combination possibly. And then print knows what to do. It runs it through a process and it sends the result to the standard output. And that's what you did up through task 5 so far in our Jupyter notebooks. And so now we're going to take a deeper look at data types of variables. The thing about a variable is it's just a container. We already know that they can be reassigned, so we can start with a variable that has a string in it, and later it can have an integer in it. And so that dynamic typing of variables is very special about Python. Some other languages have that, but many programming languages don't allow you to do that. They make you determine the type, and it can only hold that type forever. Well, that's not true with Python. So Python, whatever you assign into the variable, at that moment, the variable becomes that type of data as a holder. And so that's kind of cool. It's more flexible, it's more forgiving, but it means we need to learn how to understand what the type of a variable is. Another thing that's happening here, we can see, and notice we've just gone past task 5, and we're scrolling down, and we can see that we're learning about a new data type, a new data primitive called a decimal or float. And a float is a decimal number, basically, a non-whole number. So an integer is good for a whole number, but a float is for anything that has partial value below the integer value. And so that's another type that we now know. And we can see, for example, here's an example of a variable that was initialized and assigned a value of 22. And here we see it, so x equals 22. But if we come down here, and it looks like there's something a little funky in my code. Let me see if I can fix this. Maybe if I take this like that. Let's just try that and run it again. Oh, it doesn't want to look right. It's a little funky. Let's try it like this. Nope, it's not. I don't know if you see what I see, but it seems like I've got a bit of a problem here because my code in the Jupyter notebook looks a little funky. Oh, it's starting right there. That is where it was. Okay, and then down here, and I think that will be okay like this. And let's just see. Looking better. And I'll just put one right here. So if you don't see what I'm doing, I am fixing part of the Jupyter notebook as we go so that it reads better. It had a few formatting issues because of a bit of legacy code. So I just did a little fixing on the fly. So the type can be changed. So here, if we now reassign x to I am a string, now the type of the variable is no longer an integer as it was with 22. It is now a string variable. So that's pretty cool. And now if I were to come down here, we could actually design, for example, a template of a letter or something, and we can use a variable like name, and we can refill it with data from a list, for example, and print names so we could actually make reusable code. And so we can kind of see it happen here. So if I run this example, I see that test value was 22 and now it's Joanna, and when I print test value twice, I get two different things because the container was holding different things when the print was called, the function was called. So when you use a function like print, when you actually use it, that's called calling the function. So we just called it twice here in the example, and we see that we got 22 and Joanna. Assign a variable and print the value. So here, assign a string and print the string. You can do that. I think you're ready. Modify the value of the variable. Use the same name, so student name. You can give it a different name here. Print it, so print it, and then assign a third value and print it again. And the idea here is to learn that that container can hold different things, and it won't matter to the print function. It will go find what is currently in that variable, and it will use that to perform its print functionality. So that's what you're really learning here. That's the idea, is that variables can change in terms of their current value they're storing. So here we can assign to bucket, and then we assign an integer, and we print, and print knows what to do, and it sends it to the standard output. So I think that's pretty straightforward. I think you can follow along with that. What is also interesting is that we can test the type. So we're about to learn about type, which is our second built-in function. So print is a built-in function that comes with Python. It's just there, and we can just use it, and we don't have to worry about where to get it. It's just ready. And same thing with type. Type is already there. And so if we use this built-in type function, we can feed it either a direct string or other item. Like here we've fed it hello world, here we fed it an integer, here we fed it a decimal or float, and we expect that it's going to tell us what each of those is. And here we can actually feed it a variable. So sometimes you don't know what's in a variable. You might be running into an error in your code and you need to test and see what's in the variable. And this is how you do it. So if I run each of these, so if I run this example, it tells me str, which means string. If I run the next one, it tells me int, it means integer. Run the next one. I want you to run all of these in your notebook. So as we do these examples, I want you to pause the video, go right back over to the Jupyter notebook, run the examples. If you have to replay the video or roll it back, you can, and then do the examples and the tasks as we work through these Jupyter notebook walkthroughs. And you can see that even in this last example where we fed it a variable, it was able to find the value that's being stored in the variable and get the type of that value and send it to the output. So there we got the string, and we understand that. So down here, a whole number, so that'll be an integer. Word in double quotes, that'll be a string. Single quoting, still a string. Double quoting, so that'll be, again, a string. Type of 12 will be a string. Here we're going to have an integer. Here's an integer. Here is a float because it has a decimal place, even though it's a 0. And of course, this one has a partial, 0.55. That will be another float or decimal. And then here, find the type of the type 3 statement. Find the type of the type 3 statement. So what if we do type 3? It's a type. Very interesting, huh? So you can do that too. I think you're ready for that one. So down to part 4, we're going to go a little further, and we're about to learn about errors, which are your friend. So you should be ready for errors and welcome them, because what we have here is a safe environment for learning. And what that means is that you have the ability to make errors, learn about them, and fix them. And that's the whole point of having the coding happen on your machine as a developer. And as a manager of coding too, that's exactly what you want to do, is develop a space where your people can work and try things out, break things, fix things, improve things before they get to the production line, before they are actually running an online mobile system or store or other kind of mission critical application. So we're definitely going to be thinking about errors here in a minute. So let's keep going down. So we've learned about numbers, strings, things like that. And it turns out that in Python we have some built-in operators we can use to make things happen, like the plus symbol. It does exactly what you would expect in terms of numbers. If you do 3 plus 5, you'll get 8. When you have two strings, it concatenates them. It puts them together. So if you have I wear and a hat and you use a plus, it makes them into one string. And so that works. And then if you had variables holding I wear and a hat and you use plus between them, it would do the same thing. Or if you had a variable holding a 3 and a 5 and you used a plus between them, same thing, it would add those two values together. So down here we have some examples. We can go through and test it out. My name plus Alyssa, there it is. Shoe color brown. Just for fun, we could go in here and assign some of these to a variable and then play with them. But I think you get the idea. You can see how that worked with brown. So we could have had two variables here. And so I could now come in here and say, well, what about plus shoe color? Because shoe color is now, I ran this cell already. It's at, it was the 21st thing run for me. And because I ran it, shoe color is a variable now stored in memory, which means I should be able to use it here on this line when I run this line after the prior one. Oh, and I wrote show color. So look, I got an error. It tells me there's a name error. It doesn't know what show color is. And I look back and I go, oh my gosh, it was shoe color. So I got to change it to shoe. And now I can fix my code using that error. And now I see I would like to have a space here. So I'm going to run it again. And now my name is Alyssa Brown. And then I could even do something like dot capitalize, and now I've got it looking like a name. So you see how we can use string concatenation and we can create a phrase. We could store the created complete phrase in a variable and then use it somewhere else. Similarly, we could save this sum in a variable named total or something like that. So very easy to do. So add 3 integers, run this cell, add a float and an integer, add the string with a string of your first name, create variable small number, big numbers, assign them numbers, then add the numbers, then assign a string value to the variable first name and add to the string. So I think you're ready to do all of those things. You can use print to print the result of multiple lines of output. So down here we can see we're going to add 2 numbers. We've got a first name and we've got a greeting. And so if we run this, we can see add 2, 50, happy birthday Alton. Maybe he's 50 years old. Then down here, run the code for integer addition and variables and a print function. So again, remember we can make it an addition and store it into a variable and then print the variable later. And so let's do that. Okay. And then what we could also do is we can actually do 11 plus int sum. So we can do it like that too. And so now we can see that we can use any combination of variables that have integer types plus integers themselves and feed them to a print statement or to put them into another variable, and it will work. Here's string addition. So if we do string addition, there we go. And what if I were to go, remember here we have hat message. I do not wear a hat at dinner, so I could do hat message plus and run it again. I do not wear a hat, and I want a space right there, at dinner. There it is. And what if here I could have gone through and remember we had a first name, and I can do that. And what if I want a space now? I can't get it into the variable, so I need to put quotes and a space and a plus, and now I can get, then I can use this value from first name from up above because it's already in memory in my Jupyter notebook. All right, so now perform string addition. So you're going to add something to this string. I think you're ready for that. Add 2 or more integers. So here, instead of just 0, add some up and print them. And create and print a new string variable that can. So I think you're ready. So you're going to use new message, and you're going to use a string literal, and that should work. Errors. So we saw an error earlier. Here I can see there's a type error, can only concatenate a string to a string, not an integer. So we had here, my number is, so if I want to fix this, I would have to come in here and make this into a string, like that. That's one way to do it. We're going to learn another way later, but for now, that's the only way you know. But that will solve this problem, because if I do that, if I change this over, and I run it like that, now it's working. Okay. All right, and so let's go on down, type error. So here we can see we're going to get some other errors, same errors. So you can fix this, int and string, we just saw that. Down here, same problem. You know how to fix this, so you'll have to fix it in the source. And then down here, we're going to run this again. And here it's a question for you to imagine. It's not an error issue, it's more, what is the type? So if the type is 3.3 is a float, and then you add them together, only a float can represent a decimal. So the result of an integer plus a float is a float. It has to be. It will always be. And if you were to do division or multiplication, especially division, it will always result in a float in Python. So there are things, notice there are different kinds of errors. We just saw type errors. We saw a name error earlier, but it's also possible to have syntax errors, and those things can help you. So like if you forget to put the last matching parentheses on, I had a syntax error of sorts in the markdown earlier that I fixed, and so that's another way that syntax errors can happen. And you can see, you know, matching quotation marks, things like that. That's how syntax errors happen, is when there's some formatting that's supposed to be there that's not there. So if we go and we run this next one, go ahead and run it, and I got a syntax error. Now when you get an error, I want you to pay close attention, read the error. It's telling me it's in this line right here. And when I look closely, I see a single quote here and a double quote here. I probably have to match my quotes and run it again, and I fixed it. So that's what you're doing. Whoops, that's what you got to do. Is you've got to, I hit undo, but it took me too far. I'm going to go back down here to here. So this one, like that. So that's what it was, and then I fixed it, and now it works fine. So here I just went back. If you misspell prin and you run it, it tells you name error because it doesn't know what prin is. And it tells you what line. And so I come in here and I add a T in and I run it, and it fixes it. It knows what to do. So the error is helping me. Review here. Notice here, if I run this one, it says it points to where the problem is. And I see that I'm missing a parentheses. And if I put it in and run it, it works fine. Down here, what if I do this one? Aha, wrong order. I needed to close the quote and then have the parenthesis, and that would work, but I typed them in the wrong order. So these errors are your friend. You need to pay attention to them and go through all of these in task 11, and let's see how you do. Okay, so the final thing we're going to do here is just a little bit of fun. You can see when people write programs, they write them usually with a graphical interface, but some old ones are actually written, and certain system softwares are written in the terminal interface, which we'll get more familiar with later. That terminal interface, there are only certain ways to produce graphic design that makes people pay attention, and so one of those things is ASCII art. So for fun here, you've got a task to create some ASCII art, and you can try that out. Notice how it works. You put some spaces, you try to line it up, you use a bunch of print statements, and then you can do it. So go ahead, make the flying bird, create the letter E. I think you're ready for that, and you should enjoy it. That's actually pretty fun, and we'll stop here, and then we'll pick up with the next video to finish out going through these other pieces of our first tutorial.